All right, guys. How's it going? This is just going to be a continuation of the next of the chapter that we've been working on. This should the homework in these notes should go on page 61 and 62 of your notebook. Like always, feel free to pause and rewind to see anything that you guys don't understand. Okay. So this lesson's pretty simple. All right, trigonometric functions are useful for modeling real-life periodic motion, such as waves and sound waves. Pretty cool. Often these waves are described using frequency. Frequency is the number of cycles in a given time. The frequency of a graph of a function is the reciprocal of the period of the function. So frequency is the reciprocal of the function. Okay. All right. So feel free to pause, copy down. Gonna move on. So I'm just scrolling down. Some examples would be periods 2/5. That means that the frequency is 5/2. All I'm really doing right there is I'm just flipping it around. Okay. Cool. Let's move on from there. Let the amplitude equal 1. So the amp is equal 1. Write a sine function equation to represent y is a function of time, then graph the equation. Okay, so we remember what am I doing? Freaking out. Sorry about that. Totally was not spaced out correctly. So it says, let's reread this problem. Elephants can hear sounds cool as low as 5 hertz, so 5 cycles per second. Okay, so that is the frequency right there. Find the period of the function that models the sound waves. So we know that frequency is 5. That means that the period is the opposite, or just the reciprocal, so it's 1/5. So the period is 1/5. Okay, let y equal 1. The amplitude is equal to 1, so y equals, I want to do something a sine of bx, right? The idea that I wanted that the idea is that from here, I know 1 is my amplitude sine. My period is 1/5, right? I want to find b. If you guys remember from last lesson, the period is 2 pi over b. And I want to solve for this b right here. So the way I do that is cross multiply. So I get 10 pi is equal to b. So it's 10 pi x. That would be my equation right there. All right. And once again, just because this is the period, b is not 1/5. B is the value underneath the 2 pi right there. All right. I want to graph that. So y equals 1 sine of 10 pi x. I already know my amplitude is 1. I know my period was what? 1/5? 1/5. 1/5. So start at 1, -1. Remember, throw 1/5 down at the end. I'll break my graph down to fourths like that. So 1/5, I want to multiply by 1/4 to find that first coordinate. So I get 1/20. So this is 1/20. To find the second point, I take 1/20 and I multiply by 2. Because it's the second point, I multiply by 2, so I get 1/10. And then to find the third coordinate, I take 1/20 times 3 to get 3/20. And I just follow the pattern of signs. So middle, high, middle, low, middle. Cool. Nothing too crazy about that. So I'm just going to move on. humans can hear sound with frequencies as low as 20 megahertz. So part A finds the period. So if frequency is 20, that means that the period is 1 over 20. Part B, amplitude is 1. I want to find a cosine equation. So y equals 1 cosine of bx or b theta. It doesn't really matter whether I use x or theta. Yeah, that doesn't really matter. Like sometimes I use x, sometimes I use theta. I want to solve for b. Remember, it's 2 pi over b is equal to 1 over 20. You want to cross multiply to get b is equal to 40 pi. So y equals 1 cosine 40 pi theta. And that would be my answer. I trust that you guys can graph on your own, so I'm not going to do that. So I'm just going to move on. Try to make this a little bit shorter of a video. Okay. Tangent. Let's go ahead. You don't really care. The only thing about tangent that I care about is the period of the tangent. Period of a tangent. Okay, period of a tangent is 180 over b or pi over b. No longer 2 pi over b. It is pi over b. Okay. All right, so it's pi over b. Tangent is the only one that's kind of weird and janky and funky. Okay, pi over b. So I want to find the period of y equals tan 2 theta. So tan is 2. So it's going to be pi over 2. This is b. That's my period. I can't really reduce that. I'm not doing 2 pi over 2. I'm just doing pi over 2. I want to graph. Tangent is done differently. This is the only one that's done weird. You want to create more even on both sides, okay? So you want to make your graph even on both sides. Remember for sine, cosine, how we kind of pushed everything to the right? For tangent, we're keeping it even. The first thing that we're going to do is we're going to break it into fourths like this. 2 on the left and 2 on the right. Okay, that's important. 2 on the left, 2 on the right. What you're going to do with your period, pi over 2, is you're going to multiply it by 1/2. This first coordinate here is pi over 4. So once again, to get pi over 4, you take your period and you multiply it by 1/2. What's kind of cool is that if you know that the right side is pi over 4, then the left side is negative pi over 4. Now to find the inner point, we're going to take pi over 4 and we're going to multiply by 1/2 again. So this inner point is pi over 8. I'm taking that point and I'm just dividing by 2. This is negative pi over 8. My amplitude is 1 because there's no number in front. So 1 here, negative 1 here. Tangent's kind of cool. What you want to do is you want to, at the end, you want to draw vertical asymptotes. There are vertical asymptotes for tangent because there are certain coordinates for tangent that will not be, that will not equate to anything. Tangent just has a pattern, so you have to kind of just memorize the shape. And that's it, you're done. So you kind of have to memorize the pattern, the shape of it, and that's it. Okay. I want to find the period, so go ahead and pause it and try it on your own. And then when you unpause, I'll have it worked out for you. Okay, so your amplitude here is 1. Is 1/2. Your period, notice that there's a 1 in front, so it's just pi over 1, which is just pi. So I'm just graphing. Put 1/2 up top, negative 1/2 on the bottom. Next, what I'm going to do Next, what I am going to do is I am going to take my period, or I'm going to break my graph into 4 parts for tangent. Remember, tangent's special, right? You want to do it like this. I'm going to take my period, which is pi, and multiply by 1/2. So that's pi over 2. So pi over 2 is here. Negative pi over 2 is here. Take pi over 2 and multiply by 1/2 again to get pi over 4. So this is pi over 4. This is negative pi over 4. Draw your vertical asymptote. Follow your pattern. Notice how they kind of line up here, which is kind of important. And then graph it. Please don't make it a line. Like, it should be curved. Like, that sucked. Like, do better than me there. Not that much better. Let me do it one more time before I give up. That's a little bit better. It should be more curved than a line. Okay, so just take your time. Draw it right. Okay. All right, moving on. The next 3 things that we're going to do is secant, cosecant, and cotangent. I'm not too worried about this. But here's the key concept. Graph the original sine, cosine, tangent, the location. So let's go ahead and just pause it here. Let's copy that, and then I am going to move on. Cool? Cool. Okay, so I want to graph this. Y equals 2 secant theta. Okay? Pretty simple. Amplitude is 2. And you notice how we're doing secant? I want to pretend that that's really cosine. Right? Because secant and cosine are partners in this. So that's really cosine. If that's cosine, then the period is going to be 2 pi over b, which is 1. So it's just 2 pi. So I'm just going to graph out a cosine, which you guys should be good at now. 2 pi here. To find that first coordinate, you want to take 2 pi, divide by 4, which is pi over 2. Take that, multiply by 2 to get pi. To find the third one, you take pi over 2 times 3 to get 3 pi over 2. Okay, so like I said, that's probably the most important part for you guys to understand. How to break your graph down to fourths, okay? Next, what I want to do is I understand that it's cosine, so I'm just going to draw the coordinates for cosine. So cosine starts high, middle, low, middle, high. And I'm going to make a dash. Because remember, I'm not really trying to do cosine. I'm technically doing secant, so I'm making a dash there. And do you guys notice wherever it crosses the x-axis, I'm going to have a vertical asymptote through. Wherever it crosses the x-axis. These coordinates right here, the high and lows, I'm going to have parabolas coming from there. And that's it. That's my secant graph. It's just graphing cosine and then just doing another step or two. Nothing too crazy about that, to be honest. Okay. All right. Moving on. Okay. I want to do this problem now. Y equals cosecant 2 theta. Remember, that's really graphing out sine, so that's y equals sine of 2 theta. So amplitude is 1. Your period is 2 pi over 2, which is just pi. And you want to just graph like normal. Break your graph into fourths, and you're really graphing sine, right? Cosecant is really sine. So you want to just graph sine out. So 1, 2, 3, 4. 1, negative 1. Throw down pi at the end. And by now, you guys should be better at this. Pi over 4 here. Times it by 2 to get 2 pi over 4, which is pi over 2. and then 3 pi over 4. That one's pretty simple. And remember, I want to graph out sine. So middle, high, middle, low, middle. And I kind of messed up right here. Do you see how I kind of made a solid line? Remember, I'm graphing out cosecant, not sine. If I was graphing out sine, I'm good, but I'm graphing out cosecant. So I want to make a dash line or a dash curve. And wherever it hits the x-axis, I'm going to have a vertical asymptote there. Then wherever these high and lows are, I'm just going to have parabolas that go away from my center. And that's it. I'm done. You have to make dashed lines. That's really, really, really important, okay, for those things to be dashed. Cool? Cool. Okay, moving on to the next one. I want to teach you guys how to do y equals 3, I don't know, cotangent of 2 theta. So we're doing cotangent. So cotangent is a little janky, for sure. Okay? It's a little weird. Like, nothing changes. Amplitude's still 3. Your period, it's going to follow the period of tangent, which is pi over b. So it's pi over 2 for this. Cotangent is not done like tangent. And what I mean by that is that you do this exactly like how you would do sine, cosine, and so on. Meaning everything is skewed to the right. You're going to put down your period at the end. And you take your period. You take your period. And you multiply it by 1/4 or divide by 4. It doesn't really matter. Pi over 8. And you break it down like how you normally do. Pi over 4. 3 pi over 8. Okay, that's me multiplying by 2. That's me multiplied by 3. Your asymptotes for this one is going to be the ends. And that's just something you guys need to memorize. That's probably the easiest way of kind of going through this. It has kind of the flipped effect of cotangent. God, that sucked. Nope, not. Tangent's always the hardest one for me. Okay, so it looks like that, kind of curved. Okay, that's pretty much all I have. I do want questions and reflections for sure. The big takeaways from this is knowing the steps and process of how to do tangent. Period, take your period, divided by 2, reflect it, divided by 2 again to find these coordinates and memorize the pattern, right? For secant, cosecant, you're just graphing sine and cosine, making them dash lines, and then, whenever it hits the x-axis, have a line there. And then tangent, cotangent, is just a straight up memorization of it all. All right, so that's that. Good luck with that. Email me or contact me through that Google Voice number on there, or leave me a Google comment if you guys have any questions about this. I'm thinking about doing an office hour next week on Zoom so that you guys can have any questions that you guys may have answered. So just keep a lookout for that, okay? All right. See you guys.